of simple as well as compound microscopes as well as telescopes. See, suppose you have an object of height h or something. Suppose this is the eyeball and this is the retina. I'm just drawing a small line here, horizontal line over here. Suppose if you're having an object placed here, this is an object of height h. So the size of the image as perceived by the eye depends on how much angle it forms at the retina. Suppose from here, whatever light goes through the center, it won't deviate, but rest of the lights, it is depending on this angle. If this angle theta is more, then the size as perceived by the eye is more. If this is the object and the image on the retina will be formed upside down, and that we view as the upright image. Okay, so what about the other lights? The other lights that come from the object go and form at the same size. I mean, here is how it forms the image. Let me take the case of the relative sizes. Suppose you are having a very tall object. Okay, from here the object forms, whatever light goes through it forms. So this is the angle subtended at the retina. Suppose if you choose to have a small object here, but you are keeping a small object closer. So if you look at it, the small object is now able to form more angle at the retina. Hence, this small angle, the small sized object, the small object is now perceived bigger than this. Imagine that there's a bus standing in front of you and you're holding a small credit card in front of you, but because you're holding the card so close to the eye and the size of the card perceived by the eye is bigger, and this card is able to block the view of the bus. This is what the relative size of an object perceived by the eye depends on the size of the object, or you call it image, perceived by the eye is directly proportional to the angle subtended at the retina. It is the angle subtended at the retina. The more angle, then the more is the size. So we can call it magnified. The object looks magnified if it subtends more angle at the retina. So let me take the case of two simple things. So one thing we have understood is if the object is closer, it subtends more angle, thereby we see object bigger. But the point is, every eye cannot see objects closer than certain distance. So for a average human eye, healthy human eye, 25 centimeter we call it. It is different for different persons actually. Some people could see objects clearly at 20 centimeters. Some people could see objects clearly at even 15 centimeter. When you kids are, let's say you are in +1 or +2, you should be able to see objects clearly as close as 15 to 18 centimeters also. But for an average human eye, they call the average distance, which is supposed to be 25 centimeters. We call it D, which is near point of the human eye, or we call it least distance for clear vision. If you keep the object here, then it will subtend less angle, but if you keep the object here close by, it will subtend more angle. But you cannot, just because bringing the object closer forms greater angle doesn't mean that you cannot bring closer than 25, because if you bring closer than 25 centimeters, the object cannot be seen by the eye clearly. Object will be blurred. Okay, so this is the first basis. I'm going to go into this. What are the ranges of eye? So objects can be seen by the eye if the object is at the near point. That means least distance for clear vision. And the fact that the moon or the sun or stars you are able to see, the eye is able to focus up to infinity. So the range of the human vision, range of human let's say human eyes ability to see objects is ranging from 25 centimeter to infinity. I call it range of human vision is from near point, which is on an average 25 or 20 centimeters, to infinity, because compared to the dimensions we deal with, moon is about 1.3 lakh kilometers away. I mean, sorry, it's not even 1.3 lakh, it's like 3.9 lakh kilometers away, and you see sun is 15 crore kilometers away. The fact that we are able to see them is that the eye is able to, even stars are trillions and trillions of kilometers away, yet we are able to see them because the eye is able to see objects from near point, which is 20 or 25 centimeter, to a far point. We call it far point infinity. So the continuation of this we'll see in the next video.